Oil Treatment International, OTI, is a Swiss-based company which brings to market a new and revolutionary non-toxic granulate called SOT11. SOT stands for Solid Oil Treatment. This product was developed over a period of more than 20 years in order to remove oil spills from the surface of the sea. It ensures complete degradation of spilled oil by natural bioremediation. Consequently, a completely new deployment technology had to be developed in order to apply the non-toxic granulate to the oil on the water's surface. In cooperation with our various partners, this technology was extensively tested in natural, sensitive environments by permission of the Thai authorities. In this film, you will witness a live exercise in the subtropical region of Pattaya in Thailand. For small spills, the granulate is brought to the site in 25-kilogram bags. This situation requires a smaller size deployment device, which would also be used in harbours or at river locations. SOT11 consists of granules from non-toxic, totally natural minerals, which are chemically inert. Before the product is applied, the thickness of the oil film is measured with a device which is also a proprietary development by Oil Treatment International. This ensures that the appropriate amount of SOT11 is applied onto a given polluted surface. For large oil spills, a 20-foot container was converted to ensure quick transport and swift action at sea. The polluted water surface is first dusted to prevent the oil from spreading further. For medium-sized spills, the SOT11 product is filled into weatherproof standard big bags, which fit directly into an easily transportable rapid response deployment device. We now dive into one of the most fascinating natural underwater habitats to be found in Thailand. The spectacular flora and fauna are intact. Numerous microorganisms support each other, maintaining a balance in the marine ecosystem. Various signs positioned underwater mark a precise area which was set up in advance. Some samples are taken prior to the exercise in order to ascertain the true picture of the natural habitat. All samples taken are supervised by an independent certified marine inspector and are subsequently shipped by DHL to BioAquatic in Carrollton, Texas, USA, a scientific marine laboratory for independent lab analysis certified by the EPA, the U.S. Environmental Protection Agency. The oil in the exercise boom is dusted, and in a fast surface reaction, the spilled oil compacts into small particles which fall to the bottom of the sea. Crude oil has very complex and varying molecular structures, consisting of hydrocarbons and additional trace elements such as sulfur, oxygen, nitrogen, metals, heavy metals, and powder of diamonds. Through the process of adhesion, triggered by the deployed SOT11, the oil is trapped and sinks through natural gravitation to the bottom of the sea. Immediately after the adhesion process, the water column is almost clear, and no interference with sea life occurs. Already during the sinking process, further samples are taken to verify the right ratio of the product in proportion to the oil requiring treatment. After the particles have sunk to the bottom, flora and fauna continue life as usual. Based on the existing physical properties, the oil is firmly bound to the SOT11 and is in no circumstances released back into the water column or to the water surface. In regular stipulated intervals, samples are taken to be tested again by the independent marine laboratory. Once the SOT11 with the adherent oil has touched the ground, the bioremediation process starts. With the help of microorganisms, biodegradation sets in until the oil is transformed into water and carbon dioxide and is thus completely metabolized. In a complex interwoven network, various microorganisms such as fungi, algae, and numerous hydrocarbon-degrading bacteria are responsible for the oil-degrading process. Besides the nutrients nitrogen and phosphate, newly released hydrocarbons promote the development of a new and growing population. By these prevalent nutrients, in conjunction with the sunken crude oil, a process is launched which transforms the crude oil into water, carbon dioxide, and biomass. This process accelerates the rampant growth of the natural oil-degrading bacteria. The intermediate products are degraded by secondary consumers. Released carbon dioxide is processed by photosynthesis into oxygen and carbohydrates, which are absorbed by the natural environment. This graphic illustrates the process in aerobic environments. A similar complex process takes place in anaerobic, predominantly deeper waters. In Thailand, this process took only 4 weeks, but already after 7 days, the seafloor was almost clean. Only a few spots of the original sunken material could be found, and in size, these had diminished significantly. Life underwater remains unchanged. The duration of the oil metabolizing process depends on the prevailing climate and the present flora and fauna. Within a time span of 1 to 4 months, the oil will be broken down. In 7-day intervals, as requested by the authorities, and over an entire period of 104 days, regular samples are taken to verify the bioremediation process. The final scientific laboratory analysis report from BioAquatic confirms. The results clearly show a 99% plus reduction in oil contamination when comparing the Field B contaminated sample received on the 3rd of June 2008 to the sample received approximately 30 days later. OTI's original thesis has thus been verified. If nature, over millions of years, had produced something like crude oil, it must have thought of a solution for it as well.